Facebook has been asking this question for 45 times over the past 6 months. We're given the array that contains certain numbers of the linked lists. Each linked list is sorted in ascending order, and we need to merge all the linked lists into sorted order. Notice that for each individual list node, this is considered as one node, where its value is 1, node 4 and 5. So if you're calling the node at index 0, from these attributes, the value inside this node is equal to 1, and the list node at index 0.next is equal to the next node, which is for the links to 5. And we have multiple list nodes. So eventually, we're going to merge all the nodes, and we're going to break them down into one sorted list. I'm going to talk about the brute force approach, which is acceptable for this question. And the intuition is that instead of sort in nodes, we can actually sort in array, which is more straightforward. For each node, we can simply extract the value in order to build the array. It is more clear that you can see the graph here. We break each node into the array, we sort the array, and then we finally restructure the list nodes. And this is the Python code. First, I declare the empty array variable called nums. This is where I stored the sorted array later. For each array in the list, so the array is actually the list node. And I declare the head as a pointer. So initially the head is at the first. For each array, I need to make sure that the head pointer is traversed to all the elements. So I said while the head has element, I simply just append the head's value and I traverse to the next. So this will goes like this. There is one edge case that the input is empty array, so I just simply return none. After the array that's been sorted, I also need to build the list nodes. Again, I'm creating the head variable. I'm using the first element from the list, which is node 1. And I'm calling the constructor of list node here, so I'm creating the object that I point the head to the node 1. I assign the temporary variable to the head, so the temporary variable is also points to the first node. I have the for loop that's starting from the second element to the last. So I assign the temporary.next to the next node. So you can see how I build the links here. And then I move temp to the second element, and so on. So eventually I will link all the nodes, and they are in ascending sorted order. Finally, I just need to return the head node. For this approach, the time complexity is initially, while we are building from the list node into array, we have an time complexity. And then we are calling the sorted algorithm, which will result into nlogn. And finally, we are restructuring from the array into the list node. So we have O(n) time complexity. So at total, the time complexity of this approach is dominated by the sorted algorithm. Next, I'm going to talk about the heap approach. We also call heap as a priority queue, because for each node, they're already sorted. So we can actually take the advantage of it. We can start to sort and merge the head of each node. So by pushing each head into the main heap, the main heap is also called a binary tree structure, that its parents is always smaller or equal to the child nodes. And after the push, that will result into the main heap just like this. Now we know that the root of the main heap is always the minimum. So we pop the node from the main heap, we add it to the result, and we check from the list if the node has the next. So in this time it has 4. So we are adding number 4 into the main heap. Because of the properties of the main heap, when there is a new node that's been added, it will restructure to maintain that the root or the parent nodes is always greater, so it's always smaller than the child nodes. Again, we'll continue to pop the root from the main heap, and we add it to the result. We also need to check if node 1 has next. In this time, it links to the node 3. So we are adding node 3 into the main heap. And we continue to pop from the main heap, add it to the result, and check if it has next, and push the main heap again. We pop and add until there's no one left. And here's the Python code. If you are familiar with the heap structure, you'll know that the heap structure is comparing based on the value. But now we are talking about the nodes here. So by standard, in order to do a heaplified on the 3 nodes here, that results into the main heap like this. You will need to revise the comparison rules in the Heapify. And the question does not give us the flexibility to revise the rules in the list node. So you have to create your own class called the node. And inside the class, I store the list node as one of the attributes. The time complexity of this approach, it is better than our previous approach. Suppose we have k number of list nodes here. The time complexity of doing the main heap here, it's actually log k instead of log n. And at total, we have n nodes in order to build the main heap. So the total complexity of this approach is O nlogk. If you like this channel, please click like and subscribe. Thank you.